Welcome to, how do you pronounce her name?
Agnieszka Gruchała.
We'll say welcome to Agnieszka Gruchała.
Yes, my name is Agnieszka Gruchała. I'm representing the head office of Geodesy and Cartography and the GeoPortal 2 project. The purpose of my presentation is to present how we were made IT tools which use the reference spatial data and spatial services to facilitate the conducting ongoing emergency and preventive actions. To protect people and property, we must be able to transmit information efficiently and manage them. We need to respond appropriately and analyze information. We must be able to manage human resources. In Poland, this task performs the emergency notification system, in short called SIPR. Effective functioning of the emergency notification depends on modern IT and telecommunication tools, which allow to rapid response and analysis of the crisis situation. IT tools are used at every stage, from notification to visualization. System for notifications on emergency number 112, which enables adoption of information from citizen and about place of incident. Systems to review of the situation, to manage of human resources, and dedicated networks to provide secure and reliable communication, and a system for spatial visualization to analysis of the situation and making decision about the allocation of forces. In Poland, spatial visualization in the emergency notification system are provided by a universal map module, in short called UMM. This is the first concept in Poland which linked business needs of public entities whose operational actions must be based on the reference spatial data and spatial services. The goal of universal map module is to support operational activities from emergency services through the set of applications which use the reference spatial data and spatial data services. The main task of UMM is to visualize a place of incident or any other places. However, UMM have any other functions. About these functionalities, I will tell you later in the presentation. Universal Map Module was created in GeoPortal 2 project, which is realized in the head office of Geodesy and Cartography. The president of the head office of Geodesy and Cartography, as the Surveyor General of Poland, manages the central geodetic and cartographic resource, includes orthophoto, topographical data, administrative boundaries, points of addresses, and any other. Also, the establishing and operating the geoportal as a central access point to spatial services is the task of the Surveyor General of Poland. More about Polish geoportal will tell you Eliza Asendy tomorrow at session Making and Using Geoportals at 15 to 3 p.m. And about Geoportal 2 project will tell you Marcin Grudzień in the session Tales from the Inspire implementation, from plans to practice. Tomorrow at 11 a.m. UMM has been developed upon requirements of the emergency services. Police, fire services, emergency notification centers, and medical services. But UMM can be used by any other who needs spatial visualization with special functions. The UMM uses the reference spatial data from the head office of geodesy and cartography and geospatial data from entities who are using the universal map module. And UMM can use the SDI module solutions in the area of management and access to spatial data. This is a SDI module. On the slide is presented logical architecture UMM. On the left side are presented GUGIX systems with Geoportal's service bus. On the right are command systems, emergency services systems, and systems on the left, GUGIX systems, are used to the collection and processing and publication the reference spatial data. UMM uses the services of security and monitoring on Geoportal's service bus. And UMM has interfaces to command systems. These interfaces cooperating with these command systems, and UMM uses the view services published by Geoportal system. Here. Okay. UMM is located in GUGIX infrastructure and is integrated with command systems via dedicated nationwide network OST 112. Now, briefly, I will present you UMM's applications. Based on requirements from emergency services, were created 4 applications: dispatcher application, analyst application, user application, and application for mobile devices. These are the dedicated applications for users groups in emergency services. This slide presents dispatcher application, and dispatcher application based on programming interface. This application allows to present business object with map visualization as a background, visualization of reported events. This application can send information to mobile device for mobile client. And analyst application. This is a desktop application. This application allows to conduct attribute 2D and 3D spatial analysis for Google and partners data. Application allows to creating map visualization for the purpose of operational maps. This application can be used to making predefined analysis for any other users. And user application. This is a web application, and this application is for users who need only visualization of operational data on maps, visualization of result of analysis, or visualization of result of searching. This is different maps collection for user application. And mobile client. This is the desktop application for mobile devices, and this application is dedicated for users who need to move through the terrain. This application allows to search addresses, responsibility area, allows to navigation. This is a UMM in using. On the slide is presented Police Command Center with our universal map module. Our partners and users of universal map module: police, state fire service, the emergency notification centers, and emergency medical services. During the creating universal map module, we have some issues and many challenges. They are presenting some of them. First of all, UMM was a big organizational challenge. We have different partners and different requirements. We must link reference spatial data and operational data from emergency services. For example, police data are protected, and this it was a challenge for us to link this data. Okay. We must provide access to technical documentation, functional documentation, and any other documentation to check this documentation. And we provide many trainings and workshops. And everything were to us inspiration to create flexible solution. And now we can say that UMM has a flexible infrastructure and architecture, and flexible functionality and flexible interface. And some important about UMM in summary. Universal map module is universal and flexible. It has a collection of methods in the application programming interface. We name it generic interface. And the generic interface can be used by next entities who need to perform operational activities on the reference spatial data. UMM uses the data collected in the infrastructure for spatial information. The data are provided by services in accordance with the INSPIRE guidelines. And UMM is an example of good practice of INSPIRE implementation. And it's all. If you have any questions, you can write on this address. Thank you.
Thank you very much, Agnieszka.
Thank you.
Please be here just in case that anybody is intending to ask you a question. My name is Jesper Skovdal. I'm a substitute here for the chairman who couldn't make it anyway, so I didn't grab all you said, but I guess that you did. And if you have any questions, please be kind to ask them to Agnieszka now. Yes, we have a question up here. For your information, we will do a little recording of the questions. So I'd like you to all to ask your questions via the microphone, please.
Maybe it's a silly question, but I didn't understand whether UMM has developed applications, API and so on, or if it has used applications that exist in the GeoPortal.
I'm not sure if you're asking if UMM was developed and are using? No? I don't know if I could you repeat?
Yes, I repeat. So my question is, you showed us applications for security services, API, application for mobile. Is it the UMM, the Universal Map Module, that is it this program that developed all that, or is it a use? Has it used these services from the GeoPortal, from the Poland GeoPortal?
No, this application is dedicated application for these services, but the generic interface could be used by any other entities, but only via dedicated network, OST 112 in Poland. This is a public network in Poland.
We got one more question here.
My name is Marcin Gruchała. I'm working in the same project as Agnieszka, and just want to explain that the application and interfaces were some were like ready, available on the market application that we used, but some were developed and customized for the purposes of our project, to fulfill the requirements of our users.
Mm-hmm. Thank you.
Any other questions? Okay. Thank you very much, Agnieszka.
Thank you.
Let's give her a hand.
Could you help me?
Okay, I'd like Barry Evans to show up.
Hi everyone, my name is Barry Evans. I'm here to talk about the work I'm doing on a project called Cobweb, where we're using the general public, we're using citizen science to help facilitate gathering information to support flood risk. I apologise that the title that's up on here doesn't match what's in the programme. I'm not sure how that happened, but we are using an open source approach, but I'm focusing mainly on the crowdsourced aspect. So a quick overview of the background. So I'm going to just briefly say what's going on within the Cobweb project itself, some of the issues with collecting flood risk data, and then go on to what sort of data would be useful for this, to support this. And then going to talk about we're developing a smartphone application which will enable the general public to collect data, but not only data, useful data that we can use to support our flood models. And then just briefly how this actually all ties in with Inspire. So as a background, this is an FP7 European funded project. We're looking at world network of biosphere reserves. My primary focus at the moment is our pilot studies in Wales, where I'm based in Aberystwyth. And just so we're also looking at translating this over to the Greek biospheres and German biospheres, Dutch, with the Wadden Sea and Hallig Islands. The Cobweb project itself is broken into three aspects. We've got the flooding side, biological monitoring and Earth observation. Myself, I'm in charge on the flooding aspect, and my colleagues are working on the biological monitoring and Earth observation, but they all tie in together under one umbrella of Cobweb. So a few of the issues on the flooding side. A lot of the catchments that we're looking at are ungauged or have a very short gauging record. So although we're making predictions on 1 in 100 year flood events, most of the gauges only go back to like 50 years of data. So we're having to infer a lot from the models. If during the flood event itself, we can try and capture what the inundation extent is using aerial photography, satellite images, but we have to wait for the satellite to be in the right orbital position. There could be cloud cover, vegetation cover. So we're trying to get a more ground-based view of what's going on in the flooding. Asset management side, there's limited budgets for local authorities. In the news the other day, there was talk about they've just cut back 23 million off the asset management side of the rivers and waterways within the UK. And as you probably were aware of the floods in Somerset with the dredging of the rivers, and this could be some concern. So again, we can ask citizens to collect data to help facilitate this. So as I say, we're not just looking at collecting data on floods itself. If we break it into a small timeline, we can go before the flood. So asset management, as I said, citizens can look at if there's debris in the rivers, which could be a potential problem. They can look for blocked culverts. Is the drainage system coping with extreme rainfall events? During the floods, using the smartphone application, they can warn each other. We can also use what we've developed in the application to calculate what the inundation extent is, so how the flood water moves over a surface, the water damage. We can also look at water quality aspects as well further down the line. And then after the flood, again, we can ask people, so once the waters have receded, we can also ask them to continue collecting data. And all this will be stored in like a central repository for access by researchers, general public, and local authorities. So to achieve this data collection, we're developing a smartphone application. And as I say, we want the citizens to collect data for us, but the data has to be of use. So we're trying to keep the interface itself simple. So what we have on here is like, if this imagine will be your first screen, you'll have a context of what you're capturing the information about. You can then go into a bit more detail. So say like we're looking at, could be like high river levels or like waterlogged land. And then it takes you to the camera screen. So you'll take an image, capture an image. And this image itself will be geotagged and timestamped, so we know the location of where this data is captured. With a smartphone device, we can also ask the citizens to interact with the data a bit more to help facilitate the processes which we need to carry out on the information. So we've got a touchscreen smartphone, and we can ask the user to place a water marker on the surface of the water in the picture they've just taken. And we can also ask them as well to just quickly with their finger draw like a swipe line to say where the wet-dry boundary is. And again, like this is very simple. The user can do this quickly in the field, and then they can submit the data. Excuse the crude drawing. But basically the way it works is we're using line of sight to establish like a location at a distance. So imagine they've placed the marker on the water, and they've defined the boundary, and this is what we're going to then use in our digital terrain model to start doing our calculations. The issue is, however, there's a lot of uncertainty with asking citizens to collect data for us, not only with how the citizens will perform in collecting the data, but also in the device. There's issues with the GPS accuracy, the tilt of the phone, and other characteristics, so like generalization of terrain. So if you imagine that we're looking at identifying this point X, we've got like our GPS inaccuracy or uncertainty. This point X is now located within like a given area, but then we start considering tilt, the height in which they're using the phone, terrain variations in the terrain and generalization. We start getting like a zonal area of where they're capturing this data from a distance. So what we do is if we take the initial line and point as like a benchmark, we put this into our DEM, and we have the line, the termination line, and we have a simple program which will say fill this DEM up until the water, from this point until the water tries to cross that line, and we get our inundation extent from this. And now we start thinking about uncertainty. This point can move, the line can move. So if the point's moved in this instance and the line is relatively the same, we get the same pattern. If the line moves, then so on and so forth. So we end up doing, say, we did like a Monte Carlo simulation to numerous calculations of how many like variations based on the uncertainty distribution. And this gives us a derived likelihood of inundation based on a user input. So this is some data that we could potentially use. From the user perspective, all they're thinking about is just the context of the data, the photo, a bit of textual descriptions. They could even put in what they think the depth of the water is, flow velocity, asking to draw a point in the polyline behind the scenes so we can actually use the data. We're capturing information about the device itself, which we can reference for image quality control. We've got the camera settings, which is like data which is actually embedded within the photograph itself. We've got our coordinates, bearing, halo of uncertainty, like where they actually, the precision from the GPS reading. And I say like we've got our direction in which they're facing and the tilt. We can also, in the device, we're using base data, so we're using like authoritative data, like existing flood maps and predefined zones. And with this as well, we can the device can communicate directly to the server, and we can ask the server to alert them if they're in a zone of particular interest to help facilitate capturing data within an area which we feel is data lacking. We need them to get more information. So the quality and validation sides. Initially, we've got checks going on with the device. So we've asked the device to do some sort of calibration to make sure the sensors are all calibrated correctly. And again, it's capturing our GPS information and levels of uncertainty, and we have our data and metadata accordingly with this. We can then pass this on for validation checks against authoritative data, see if the data actually starts making sense, if flooding has occurred in the past from pre-existing flood models, are they actually in a zone of interest to us? And again, we can start like flagging the data with more information. Cross-validation checks. We're asking numerous citizens within an area to capture information for us. So if two people are in the same area, for instance, and they've both captured data which overlaps, this helps reinforce the observation that's being seen. I think the idea is we cannot assume that any data is captured in error, but we can start assigning like a quality aspect to the data. It becomes more likely that data is correct if it's reinforced by the authoritative data and other citizens. And this all goes back into what will be our citizen data repository. And then from a research aspect, 5 minutes, cool. From a research aspect, then we can do further analysis by comparing what we're seeing in our observations against the authoritative data. And this may help to facilitate improving the authoritative data itself to see where the shortcomings are. So Inspire, it's implicit throughout really. We say we're following good data practices, but we're building up a large data repository of authoritative data and crowdsourced data. And by following the Inspire directives, we want to maximize the data usage. So looking at educational aspects, with the general public as well, being able to access it all through a given Cobweb portal. We're also implementing an open source approach, so it'll be expansion. A lot of projects, once the timeline is finished, they kind of get put to the wayside. With this, our hope is that people will carry on using this work and can build upon it as well. It all comes under interoperability. So I mentioned before, this is a simplified view of what's going on. So our information is going to a Cobweb portal. At the beginning, I talked about we're not only looking at flooding, we're looking at Earth observation and biological monitoring. And at the moment, we've gone through 2 different approaches for the application development with the flooding, because we need access to more of the sensors. We've gone I've done a native approach, so we built it from the ground up. In the biological monitoring and Earth observation side, we're using an adapted version of some software called FieldTrip, or FieldTrip GB, which is a form-based approach. And this, again, can also collect geotagged images and textual data, but it's not capturing information yet as in terms of the tilt and accessing the sensors all the sensors on the device. But the form itself can share data with each other, and they both transmit their data to the Cobweb portal. So this can all be accessed in a centralized location. And I'd say the plan is that other external applications will be able to transmit their data to the Cobweb portal as well, as long as they're following the data guidelines. So next stages, we've got, in 2011, there was the Interoperable Geographical Information of Biospheres database, like IGIBS. So we've got authoritative data within the Welsh biosphere, and we're going to try and we're going to go over this data, make sure that it's all up to date and can come with and compliant with Inspire, and we're going to start building upon this. And so we start looking at what the metadata requirements are to ensure that the crowdsourced data will be useful. At the moment, we're on version 2 of the prototype, and we're going to roll this out now to we've got a group in Taliban that were severely affected by flooding in June 2012, and they're highly motivated to trial the app. Between 20 and 30 individuals that want to start doing testing. So we're going to roll this out within our Dovey biosphere within the town of Taliban, and they're going to start collecting information. And from that, we're going to start looking at evaluating the application and developing a more coherent test plan. Thank you. If you have any more information on this project, I'll leave this up for a moment. It's the web address for the Cobweb portal. Thank you.
Thank you very much, Barry. We have room for a couple of questions too.
My question is, when you recreate the flood inundation, do you compare data also with the geography of that specific area?
Yes, I mean we're using we've got, like I say, at the moment we use a digital terrain model for calculating inundation. So we actually put this data into a terrain model itself to work out the inundation extent. The data which the crowd is capturing is basically telling us where to start putting in the water itself. So we keep, in essence, you can imagine we're adding it to one cell, and we keep adding it to that cell to see where the water goes within the terrain. but we can also cross-reference that with other data sets as well. So we can look at on farmland, we consider infiltration rates. We consider how flooding from other flood models would actually generate the same sort of event, and see if we can go backwards as well.
Yeah. Yes, anyone else? Okay, I think we'll leave it for the next one. Thank you very much, Baring. And the next speaker is Stefania Traverso on big data.
Okay.
I think I just need this.
Okay.
Yep. Okay, and it should be on.
All yours.
So the mosaic of big data for an effective use in civil protection activities. I am Stefania Traverso, and I'm from CIMA Foundation, that is a competence center for Italian civil protection. We study natural disasters and scenarios of risks. And we have developed the DWITRA platform. The DWITRA platform is a system, WebGIS system, that is focused on multi-risk mapping, forecasting, and monitoring. And we deal with temporal and spatial data, web services, open source technology, various providers. Our aim is to build scenarios, so we need observations and forecast. We can rely on models, we can produce analysis and monitor territory with instruments, and also with non-instrumental forces like crowdsourcing or man on the field. So the point is mapping for crisis. Are you collecting only scenes? We produce various data. Static for the study of vulnerability, continuous real-time data for risk evaluation, and also for early warning diffusion, you need multiple channels. And for response organization, you use static and dynamic data, because you have to depict at the end a complete vision of what is happening and maybe which are the final effects on the field and rescue requests. So what we want is to identify at first the event. The event is composed by various parts, but the representation of this event into virtual reality needs general statements, language and tools, and various researches. After the identification of the event, we want to evaluate what is happening. So we need models, sensors, and also imagery, satellite imagery. So a good preparedness in time of peace allows to overcome problems in emergency, and the good planning starts from a deep knowledge of territory and its historical modifications. At the end, the system for collecting data must be mainly flexible, in order to last over years. So when we communicate what is happening, we use codes, keywords, and standards that allows this use allows an efficient communication to volunteers and helps to build a versatile, multi-risk, distributed DRR culture. So a scenario is not only a scene or a collection of scenes, but is also something that needs dynamic processes and observation. So not still images, but time series of spatially distributed observational data. Mainly, we can say we use an approach on uncountable sources. We need data semantics interconnections, and we study and reproduce visions that have 4 dimensions and are with multi-perspectives. So, we need to build hyper-realities and augmented reality that starts with the characterization of a spatial system, and it is composed by elements, constraints, and connections. And with the usage of big data analysis, you can, for example, transform the study of a high school that is on the left to the study of the school that is on the right, that is a school differentiated in vulnerability degrees that take into account big data sources, and so you can know in details contexts and materials and these things. But big data, when in this usage, need to be tailored, because you use local archives, national or international agencies, obviously, not non-authoritative data, but you have to rely on inspired information and other that are maybe necessary for immediate usage of civil protection. So you have to tailor this information. A case study that I propose to you is that of Sardinia, the extratropical storm Cleopatra. This event occurred on last November, and it caused 18th death and almost 1 billion of euros damages. The WITRA was able to detect these conditions, and the National Italian Civil Protection had a correct alert on the event, and this storm was the beginning forecast with the Cosmo Lamy I7 model, for example, and so in this case we use big data for provisions. But we had also big data for observations, because our rain gauges nation network measured continuously what was happening, and also we could rely on the meteorological radar network. At the same time, during the crisis and the post-event phase, in our platform, we could see sensor, but only also satellite imagery, and a lot of things that arrived from non-authoritative data. At the same time, the Copernicus service, emergency management service, was activated. And so in this case, Copernicus data were produced. And the WITRA ingested the geo maps as layers and web map services in order to add this information to the other complementary sources we had already on the platform. It was necessary, obviously, to add metadata. We could do this with our architecture and using GeoNetwork connected to our service. And another important part was the intervention of these two components that are reports from officers, rescue teams and surveyors, and on the other side, what from crowdsourcing and the usage of USHID we could harvest on the web. So we can say that everything is necessary and can be a part of a mosaic. When you add also crowdsourcing data and in general data that can help you to have a multi-perspective vision of a scenario, you need filters. So we wanted to focus at the end on these two things, that is reliability and accuracy of data. And if you use non-authoritative data, you can try to produce indexes of reliability, and only the approved ones can be added to the scenario. On the left, there is an example of a virtual survey using Google Earth and a photo on an online magazine in Italy. And obviously, you have to think very seriously to two aspects that are which usage and also which misuse you can do with this added non-official information. So, okay, we developed the EDIT project together with the Nottingham Geospatial Institute, and we are really trying to find new partners to go on these aspects. In this EDIT project, we extract and manage scenario-oriented knowledge, harvesting data from online news and tweets, and using also open source tools. We produced this concept map that is how you can divide a disaster in parts, and then we produced this database that is the operative effect of that concept map. So after harvesting data, you can try to test them, study semantic, and populate a database, also using an index that we are trying to improve and to better. And so conclusions are these ones, that considering a wide acception for big data, that is majorly sensors, citizens, reports, online news, we can say a rational usage is not complete now, but it is really a challenging task. We have to take in mind that we have non-linear systems, and so we have to produce a correct math to correlate these data, and that we represent one virtual reality, not the reality. So starting from very near realities, you can derive very, very far scenarios. So be aware of it. And thank you very much.
Yes, thank you very much. Any questions?
Yes, thank you. I think it's impressive work what you have done. Do you work together with official statistics for using, for instance, population data, or how do you do this? Thank you.
Okay, at the moment, we have just begun this research project, but we wanted to relate official statistics from the Italian statistic service, for example, with what are results of reports derived from tweets, for example, and it is possible for us, in our opinion, also to relate statistical consideration on population and minor or major elements, minor or major numbers of tweets and the news, for example. Another point is we have to study statistically also the number of reports done with devices. So this part presents semantics, but as the presentation before mine told, the cobweb presentation, the accuracy of data is important, so you have to study statistically each too. In this part, mainly we focused on words that were connected with disasters and how people uses these phrases, how people uses these words. Another component that we cannot take apart is psychology, because crowds during an event have fear or don't speak correctly. So in order to produce a good work, you have to take into account also these aspects. Thank you.
We got one more question for you. Okay. Yes.
My question is about big data, sharing big data. Once you collected big data for the Vetra platform, do you have any plans to share those big data with some other systems? For example, like urban planning for urban planning works, or any other works for a municipality or urban facilities?
Yeah, the platform can be profiled for users. So we have a special version that is for civil protection, so for technician, for example. We can share part of this data for public, for journalists. This happens usually, and we produce web services mainly. So under agreements, we can produce and share everything you need. Okay. Thank you.
Thank you very much. And the last speaker of this session is Lyseen from Denmark. We'll be talking about public health and Inspire.
Yes, my name is Lyseen and I'm from Aalborg University, and we made a study about the Inspire compliance of health data here in Denmark, and just to try to inform you about how this spatial health is related. Well, then we have had health analysis, spatial health analysis for more than 200 years, back to the 1790s was the beginning, and probably the most famous examples, what I showed you here, is from a guy called John Snow, who is was mapping cholera cases in the center of London in 1854, and found out that it was the water sources in the city who was help spreading the diseases across the town. So that's exactly why it's interesting to actually talk about this spatial health, because if we need to understand how this disease is going to be spread and what causes these diseases, well, then we have to understand the dynamics of the diseases and how this works in a spatial world as well. As human health not only influenced by our normal by the disease, but also about how we live, where do we go, where do we work, and all these things we encounter during our day. So if we look at the disease, it's not just spread inside a country. We have to look across the borders. So just like you do with all your environmental data, which we just heard three people talk about. Well, this is the same here. These phenomena are spreading across the borders, and there's a lot of things influence our health. And one of those things, just as an example, is the air pollution. And it's not just the country itself that produces air pollution, because the air pollution is being transferred to the neighboring countries and so on. So there's a lot of information who's needed for us to really understand these dynamics of health. there's been a huge increase in this development of spatial technologies and so on. And with that, it's got a huge potential to analyze these spatial data that has been it's much easier to do the complex analysis now than it was 20 years ago. But for us to really be able to do this, we need these data to be structured, we need them to be accessible, we need to be able to understand the metadata of the data and so on. So right now there's not really any structuring of this, so we need this for not use a lot of time for us to be able to actually to use these data. Currently we have to make samples of the population and so on, or use a lot of time to define these data. The spatial health data infrastructures. Well, there's plenty of examples of spatial infrastructures around Europe. Just the Inspire has really started this, and every country is developing their own spatial data infrastructures. But there's very few examples of spatial health infrastructures, and because there's only very few countries who have started to implement this, and Denmark is not one of them. We're very far behind in this with health data. I just took a look at the Inspire portal, and currently Denmark have 3 data sets about health. So that's very limited, and one of them is air pollution, and another one about UV. So this is more environmental data that is being used for health. We don't really have any health statistics and so on currently on the GeoPit. So there's really a lot of potential in this within the healthcare sector because there's a huge amount of data out there. So in our study we took a look at what is required for these health data to become a part of the Inspire, and of course in Denmark of our national spatial data infrastructure. And some of the requirements is that the data have to exist electronically, they have to be nationwide and national applicable, and the data collection has to be statutory. That's what we get from the Danish part of it. Then of course we have the 5 Inspire principles, which most of you probably read at some time, so I'm not going to go through those. And then we took a look at this Annex 3 theme, which is the theme about the human health and safety. From that we draw these 6 groups of data, which we would try to look for data which was part of these 6 groups. We have the spatial distribution of diseases, mortality, incidence rates, and prevalence rates, and so on. We have health indicators, and we have indicators of well-being, which is a more sort of soft indicators in the form of stress and fatigue and depression and so on. And then we have our quality of the environment directly influencing health, which are these that already often are spatially referenced, which is our pollution, noise, and so on. And then we have a lot of these indirectly environmental influences, our physical activity levels, it's our dietary behavior, and so on. And then at the end, there's this events of injury and death. So this is all events where, road accidents, injuries in any form and any source we can get injured by. And just to show you just a little bit about how many data there is available on this subject. Well, as I said, there's huge amounts of information registered about an individual in Denmark. Just to show you a couple of them, we have a huge amount of national health registers. Just to mention, 51 clinical databases, and then a lot of other health registers. Each 3 years we do a national health profile, which is used where approximately 5% of the population is participating. And then of course we have all those already spatial referenced data in forms of the pollution and so on. So there's a lot of data out there. But the problem with most of these data, not the last category over there, is that they don't have any spatial reference. So we need to figure out how to link our registers with health information to our spatial data. Let's see how it's. So we have our basic registers is down here, and we have a lot of keys to which is going to be the keys to identify each unit in our registers. And then of course we have a lot of our health registers. We have Statistics Denmark are publishing a lot of data as well. But we need to get these linked to our spatial data, which is up here, our spatial geoportals, and we have our search and discovery geodata info up here. But in these geoportals, we can get our spatial data. We have our addresses, we have some administrative units, we have our grid systems, and so on. And through these, we can actually, because we have this civil registration of persons in a database, from that we can link between our CPR number and our address, and all our health registers are based on our civil registration number. So in this way, we are able to link all our health data to the address. So we can get the spatial reference of addresses on all our health data. So just to sum up the slide before you, and then we have, of course, for all our health, we have the CPR number. For the National Health Profile, we even got the CPR number, but also freely available right now as a statistical data set. They are aggregated on municipalities in Denmark, so there's plentiful of data out there. So to look at the Inspire compliance of these data, there's a lot of obstacles before these data can be part of the Inspire. We have a duplicate registration in many of these health registers. There's some general registers, but a lot of these clinical databases just withdraw data or are double registrations of these large national databases, and that gives one big problem with which is that we don't really know which data we should use, which one are the latest updated, and so on. So that causes a lot of problem if we want to do an analysis of the real data. Then we have, in some registers, we have a lot of bias. We have registers, in example, with a lot of, which is predominantly male population, and so on. So this has to be, this can be solved, but it's primarily solved through this last one here with the metadata, because without that, we don't know anything about the registers. And then probably the biggest part is this, because they contain this CPR number, there's some severe privacy and confidentiality issues if we want to create some publicly available data of health. And therefore there's a big need for anonymization of our data, in example into administrative units or the grid systems, where we can aggregate data into, and in that way they will be anonymized. Just a little bit about some of the privacy and confidentiality issues. In Denmark, we're actually quite liberal in our attitude towards the legally, towards the registers, and it's actually quite easy to access these data. Yeah. And that in many other countries this would be a problem, what is happening, and we are registering about everything about an individual in Denmark. Every time you visit a health facility in Denmark, it's registered, and everything about the diagnosis, treatment, everything. So this is very sensitive information, and that's why we really have to try and take care of that, because nobody want their health information out there on the web where everybody can see them. So we need to ensure the confidentiality. And then, but one of the big points about this is that it's these patient identifiable data are very critical to medical research, but they also possess a great value to the researchers, but also to the public, because the results of these research often put some new value into the society. But there will always be this trade-off here between how accurate data we are trying to withdraw from these registers, and what we can do with them, and again, how confident are these data going to be? Because if we aggregate them, then there's no problems with the security and confidentiality, but the things we can do with those are less than what we can do with individual data. We just skip that one and go to the conclusions then. So the development of an efficient spatial data infrastructure for these health data could very well be an important way to improve the quality of the, not just our access as researchers to these data, but most of all the healthcare system. And this is very important, because today there's a lot of pressure on the healthcare systems, because they're taking up more and more of the taxes you pay in each of your country each year. So the harmonization and implementation of health data in Inspire is a huge challenge, because there's so many issues that we have to take into account. There's really a need for an overall policy, both national, at least nationally, for the implementation. We need to create metadata. We need to link the spatial data, and we need to find some way of aggregating in a way that is satisfying for the people who need the data. That's not just one level of administrative data or just the grid system. We need to analyze what is the application of these data as well when they're aggregated. In Denmark, we have come far in the implementation of the Inspire Annex 1 and 2 data, but when it comes to these Annex 3 data, there's still a long way to go if we want to implement any of these. And health data is a part of these, but as I said, it's a very huge challenge to try and incorporate these in our national SDI and into Inspire. So, but there would be this process has great value for both researcher, public administration, and the private sector for if this can be done. So.
Thank you very much, Anders. Do you have any questions for Anders?
Thank you. Yes, I have another one. Because of the usage of big data, I think data protection, privacy, and confidentiality is crucial to official statistics, at least. And I think most of the data are available with addresses in the registers. Unfortunately, I didn't catch where you come from or what for you did this work. Do you work together with official statistics as well, and how do they solve these problems? Thank you.
Well, yeah, I'm from Aalborg University, so we're not really working on the application yet, because it's very far. In Denmark, we're very far to try to actually implement this. But of course, we have some rules in Denmark as well in our statisticals. Denmark, which have rules about how many people and households have to be aggregated into a unit before we are securing our confidentiality. And that's by law, but currently you probably know there's this Data Protection Act going on in the US as well, and that is going to change it all, I think, if it's going to go through, because then the national laws is not going to be part of this anymore. Then it's going to be the EU law who's going to be part of the.
Thank you. We got another question.
Thank you. Thank you very much for this interesting presentation. I can absolutely second your findings regarding the conclusion about the potential of the information that is there, but also about what's not there at the moment. So what you said, like the three data sets you found, it's pretty much the same picture in Germany. And I'm sure there's a whole lot of health information available. So maybe that makes you feel better. I don't know. On the other hand, I'd like to point out, if you think about health issues and inspire data models, don't only look at the human health and safety data specification, but also on the utility and public service one, because there you get the other side of the health discussion, besides all the diseases and stuff like that, the health services, which is really interesting information in that respect as well. Thank you.
We also, actually the service use and so on was also part of this health indicators we tried. So, but yeah, you're totally right, because there's a lot of information there as well in both the accessibility and so on. And but yeah, and there's a lot of links there to the population distribution, income, education, all these things which we have to take into account as well. So.
Thank you very much. Yeah. The last presenter, we have a little 10 minutes early break. 10 minutes before the coffee is served, I guess. But feel free to have a chat with the one that is next to you, and you can also just leave here. The session is over. Thank you very much for your attention. Your body